How do satellites fly around the vacuum of space without freezing? So satellites in low Earth orbit go around the entire Earth every 90 minutes. And during this time, they go through extreme temperature changes, anywhere from negative 85 degrees Fahrenheit to about 250 degrees Fahrenheit. So how do they deal with these rapid changes? Well, there are multiple ways. One way is insulation. This keeps the inside instruments at the correct temperature and all the outside heat or cold away. Sometimes they even put mirrors or reflective material on the outside to reflect the energy from the sun. Some satellites even use radioactive isotopes to keep the insides warm, though these are usually used in satellites that are way further out and not satellites in low Earth orbit. We don't want that radioactive material falling down to Earth uncontrollably. Looking at you, Cosmos 952. Here's the thing though, most satellites like working in the cold. In fact, many precision instruments are designed to work at extremely cold temperatures. A lot of these sensors and cameras and stuff hate the heat. Sensors that get too warm can destroy images. They introduce noise like this. Hold on. An example of what noise can do. For example, the James Webb Space Telescope. One of its sensors wants to work at negative 380 degrees Fahrenheit. For this reason, most satellites focus on keeping the satellite instruments cool. They're more worried about overheating. And there's a couple ways to do this. James Webb employs 5 sun shields. These sun shields are a passive system. There's no moving parts once they're deployed, and it keeps the instruments at the correct temperature just by shielding the sun, while the shields themselves can get up to 230 degrees Fahrenheit. Another common cooling device are fluid loops. These can be mechanically pumped or just use fluids that evaporate and condense in a flowing system. This way the components pass off their heat to this fluid. The fluid then goes to most likely some sort of radiator where the fluid gets cooled and then goes back and it just loops around, keeping the instruments cool. Just remember, when you're in space, radiation is the only way to get rid of energy, the only way to get rid of heat. This makes cooling stuff down a lot more difficult than heating things up. And the electronic components create their own heat. So we need to figure out a way to dump that effectively so the instruments don't just continually heat up. A sad example is the GOES 17 satellite. So this satellite uses a heat pump to maintain its IR sensor at a very cold negative 350 degrees Fahrenheit. Sadly, the heat pump in GOES 17 is broken. It's not dumping the necessary heat. This means images are lost and the performance is degraded. Left unattended, this can destroy sensors. And because of this broken heat pipe, GOES 17 is getting an unfortunate early retirement and will soon be replaced. Even the space station has huge radiators to dump all the heat. This keeps the humans and the instruments at a good temperature. Satellite thermal management is a very cool and complex problem. There are some fantastic resources online, including YouTube videos and just paper. And I'm sure some of you have experience of working on these systems in real life. If so, please leave a comment below. I'd love to hear about your experiences and what you've learned. So please grace us with your knowledge. Thanks for watching.